Hello everyone, here is a video presentation and manual of our deep breath simulator to simulate patient ventilation interactions and in different modes of invasive lung ventilation. When you logged in, you see the screen and you need to click on simulator and you see deep breath simulation interface, but significant difference to previous versions, like to beta version. You now have an opportunity to see more conventional user interfaces of different ventilators, like in more traditional. Important that functionality is similar in any type of ventilation, and all the features like inspiratory, expiratory hold, different lung conditions are possible in all user interfaces. So let's start overview. First group is patient parameters. Like here you can set age, height, weight, gender and ethnicity. So it a little bit affects lung size, so you see it here. For example, some parameters like tidal volume divided by ideal body weight. So it might be helpful and useful. So it affects a little bit lung mechanics and gas exchange that we simulate. Here you can set different lung conditions. So now we have, beside normal 6 different types, we plan to add more. And in our interface, you can add different types of compliance and resistance, airway pressure open, but this is for, if you want to dive deeper, please contact us. We will tell you more about this, but by default, we recommend to use these 6 presets. They pretty accurate. And you can set patient effort, respiratory rate, PMAS, and inspiration time. In this interface, and that is similar to Drager ventilators, all these parameters are here. And in this interface, that is similar to another famous ventilator, it's here. So admit patient, and you set different patient conditions and patient effort or no effort. So this is the first group. A second group is type of ventilation. So in our interface, you have spontaneous breathing, CPAP, BiPAP, pressure control, pressure support, volume control. In Drager, we have volume control, pressure support, and here we also have volume control, pressure support. So not all, but most of the like at least most common types, modes of ventilation you can try. We plan to add more later, but we would like to introduce current types already. So let's start. Let's say we have normal ventilation. We click here, play, and here we see how ventilation happens. So this is PMAS, this is airway pressure, airway flow, volume, and here is calculated parameters. So we see, let me try to put me here. Yeah. So you see here is calculated parameters. And assume we want to set some worse lung condition. For example, patient has some medium ARDS. Important, we need to click update here. This is orange button when we change anything in our mode of ventilation. And we see that tidal volume is like very low and patterns are significantly different. So we need to add some ventilation support. For example, this is pressure control. Again, we need to click update, and we have pressure control ventilation. So that's how it happens. We see already some asynchronies, but tidal volume already a little bit better. Notice please that we also calculate mechanical power here. This can be also interesting for some analysis. The same happens in other interfaces. So here we see more traditional way. Let me again to change myself in another place. Yeah. So here we see that we have, for example, volume control, and we can add some patient effort for breathing. And also we want to make, like, for example, like mild ARDS, for example. So that's how it looks. Yeah, so it takes some time to process sometimes, but yeah. So that's what we see. It's patient trigger breath. Tidal volume pretty normal, so that's maybe not bad. And what else we can do is to upload different. So first of all, this condition we can save as a bookmark. So we click here, save bookmark. We should name this. So let's say test bookmark for Dima. And this is make it public, but we don't want to make it public for any user. So we click save. And here we have a list of different bookmarks. So my bookmarks, it's this one. So that's what we just created. And this is what was that were made publicly. So for example, early trigger and volume control mode. Let's see what it is. So I just click here and it's uploaded. So now we will see something that behaves as a early trigger during volume control. And yeah, we see that indeed this is some desynchronized. So this is in effect for, but mostly it will be early triggers in volume control. Yeah, so that's what we see. We can, for example, make it a little bit more, let's say, and it will be like higher. Yeah, so this is, and let's say, yeah, so it's triggered breath already, and here is reverse trigger. So that's what we wanted to achieve at this moment, and also reverse trigger. Yeah, patient trigger breath. So we see that patient effort more often than ventilators, and yeah, it leads to sometimes to reverse trigger breath, early triggers. We can upload different, like for example, fail trigger because of over resistance in pressure control, and let's say we want to reproduce it in this interface. So what we see here, so we see patient try to inhale, it didn't work because we assume it's because of over resistance. Now it was patient trigger breath, again fail trigger, patient triggered, fail trigger. So sometimes it fails, so it's already what we wanted to achieve, but now we want, for example, to prevent it, to mitigate somehow. So how we can do this? We can, so first of all, this is pressure control. Let's reduce pressure support. I hope it will be enough, and trigger, like, let's say 1. Okay, accept. So let's see what it will be. We reduced it. We need to make also admit patient. Yeah, regular effort. Okay. Yeah. Not good synchronized yet, but it's at least there are no in effect for. So we did something. So now it's late cycling, but still it's something. So we can do now something else. So for example, we can reduce inspiratory time. Let's see what will happen. Maybe it's a little bit better already. Too high tidal volume, so because it's patient conditions is normal, so if it will be short IDS, it will be more feasible. Yeah, so that's something like this. We see that it's not immediate change, so because there is some inertia. So when we change settings, you need to wait always a couple of breaths, because we have dynamic model how alveoli open and close. So when you change something, it will take some time to find a balance. So because it's not a simple formula, it's more like it has some inertia, and it more looks like real physiology. So please keep it in mind also. And there is small variation between different breath, also as in real breath. What else? If you would like to, for example, you find something that you want to share with your colleagues, so you just click here, and then you can send it through WhatsApp or by email, and your colleague will open it, and your colleague will get exactly the same conditions that you set, like exactly what you had. So all the parameters are stored here. If you don't want, for example, to create bookmarks, so you just can share these conditions. So that's what is possible. What else? We have here we have inspiratory hold. So during inspiration, yep, it waits when patient will breathe. Yeah. We have expiratory hold. It also works. Yeah. If you want to change settings in this interface, so it looks like you need to make it this way. So you click here, you scroll. It's on Drager as the same as almost as a Drager ventilator. So now you need to confirm change here, and then respiratory rate will be higher. So if you want to change mode, you click it here. And so again, any changes here you can do. Yeah, so that's pretty straightforward. Also trigger levels. Currently it's only pressure trigger. Very soon we will add a flow trigger. And any feedback that you have, we also very appreciate. So we try to constantly improve our simulator. That's all for the moment. So please try, provide us your feedback, suggest any ideas. So we work hard and constantly change and improve our simulator. So we want to make it as most convenient as possible for you, and let's do it together.